Here we have a problem on derivative. So there is a function given over here that is y equals to e to the power of 2x, and we have to show that d square y over dx square negative 3 times dy over dx positive 2y equals to 0. So d square y over dx square represents a second derivative of y. So the square we have for d numerator represents we have to find the derivative of this y 2 times, and the square we have for x in numerator says both the times we have to do derivative of this y with respect to the same variable x, and this dy over dx is the first derivative of y with respect to x. So now what we need to do is we have to find the derivative of this y 2 times, and both the times we have to do it with respect to x. Then we'll be getting d square y over dx square, and then we have to multiply the first derivative by 3. Then we have to simplify this one, and to this result I have to add 2y, and the complete result must be equal to 0. So this is what I have to prove in this problem. Okay, now first let me take the given function, that is y is equal to e to the power 2x. I'm going to find the first derivative, that is dy over dx. That is, I find derivative of this function with respect to x. Okay, so whenever I find derivative of some stuff in the form like e to the power some variable over here, so the derivative of this stuff is the same, that is e to the power 2x. By chain rule, I have to do further derivative for the stuff I have in the exponent. So here we have 2x at the exponent. So what do I get if I find the derivative of this 2x with respect to x? So here the variable x is multiplied by 2. So whenever I want to find derivative of a product where a constant is multiplied by the variable, I have to keep the constant as it is, and I have to get the derivative of the variable alone. So if I find the derivative of this variable x with respect to x, it will just become 1. Then I'm getting 2 times 1 is 2. So the derivative of the exponent 2x is just 2. So we have to multiply it over here. So if I have some stuff that is e to the power some variable over here, and if I get derivative of this one, I have to write the stuff as it is. Further, I have to get derivative of the exponent by chain rule. So the derivative of 2x is just 2. Now we can write the dy over dx as that is 2 times e to the power 2x. That is, I am writing this 2 in front of this e to the power of 2x. Okay, now I can find the second derivative of this y with respect to the same variable x. So when I find the second derivative, I have to take square for d. That is d square y, I'll be getting numerator. That is d square means I'm doing the second derivative. So in denominator, I'm writing dx square. That is the second time also I'm doing derivative with respect to the same variable x. Okay, here this is the stuff I have to find derivative. So here this part contains variable x. So the whole stuff has to be considered as variable, and it is multiplied by the constant. So when I find derivative, if the variable is multiplied by the constant, I have to keep the constant as it is. I have to find the derivative of this e to the power of 2x. So the derivative of e to the power of 2x is the same, e to the power of 2x. Further, by chain rule, I have to do derivative of the exponent 2x. When I find derivative of this 2x is just 2, already I have discussed the stuff over here. Okay, now d square over dx square equals to, let me write, when I multiply this 2 and 2, it will become 4 times e to the power of 2x. Okay, now I got the first derivative here, and I got the second derivative here. Now I have to plug in the results over here in this expression. Okay, let me do it. Let me write this expression as it is. That is d square y over dx square negative 3 times dy over dx positive 2y equals to. Now for this d square y over dx square, I can plug in 4 times e to the power 2x negative 3 times. For this dy over dx, I can plug in this 2 times e to the power 2x positive 2. We have y over here. Instead of y, we can plug in e to the power of 2x, because in the question itself we have that is y equals to e to the power of 2x. So for this y, we can plug in e to the power of 2x. Okay, 4 times e to the power of 2x negative. When I multiply this 3 and 2, I'm getting 6 times e to the power of 2x positive 2 times e to the power of 2x. Okay, this is positive 4 times e to the power of 2x, and this is positive 2 times e to the power of 2x. So both of them are like terms because both the terms contain e to the power of 2x. So when I combine these two positive terms, I am getting a positive 6 times e to the power of 2x negative. We can write this stuff as it is. That is 6 times e to the power of 2x. Again, both these terms are these two terms are like terms because both the terms contain e to the power of 2x. So when and both of them are equal. So whenever I do subtraction between the two equal quantities, the result is equal to 0. So I have proved that the value and the evaluation of this expression equals to 0.